We'll now turn our attention to nonparametric statistics. Chapter 14 will illustrate the chapter organization for you. Nonparametric statistical test is a branch of statistical analyses that's used when the assumptions for parametric statistics can't be met. You'll recall that there are several assumptions associated with t-test, analysis of variance, and so forth. The first is that the outcome measure should be at least intervally measured. The second is that the dependent variable should be normally distributed. And the third is that there is homoscedasticity, or equal variance across the groups that are being contrasted. Sometimes we can't measure things at an interval level. We have to measure things at a nominal level, or perhaps at an ordinal level. And sometimes the data simply aren't normally distributed. Maybe they are skewed. And sometimes we don't have equal variance. In those cases, we turn to nonparametric statistical tests. Typically, nonparametric tests are less powerful than their parametric counterparts, but they are still extremely useful in certain situations if you haven't met the assumptions associated with parametric statistical tests. Let's take a look at the organization of the presentation in Chapter 14. This is essentially Table 14.1 in your textbook. We first look down the left at the parametric tests. For example, tests of association and then tests of significant difference. And you'll see the parametric tests that we've already presented in the textbook. Pearson's R, the one sample case, the two sample case, independent t-test, dependent t-test, analysis of variance, and so forth. And then on the right-hand side, we have the non-parametric equivalent associated with each of those tests. So if you can't measure things, or you haven't met the assumptions in a way that is intervally scaled, normally distributed, and homoscedasticity, you'll turn to a non-parametric equivalent test. Next, we should look at the level of measurement. If you have nominal measures as the outcome measure, then you use the associated test in the columns associated with nominal outcome measures. If you have ordinal or ranks, you use the tests on the right-hand side. For example, with Pearson correlation, or Pearson's R, the nominal equivalency tests are the phi coefficient and the kappa coefficient of agreement if you have nominal data. If you have ordinal data, the equivalent test would be the Spearman rank order correlation coefficient and the Kendall coefficient of concordance. When we now look at significant differences, we can think about the one sample case. With nominal data, that would be the binomial test and the chi-squared test of goodness of fit. In the two sample case, think of a t-test. The independent t-test, if you have a nominal outcome measure, you use chi-square for independent samples. If you have an ordinal measure, the median test and the Mann-Whitney U-test are appropriate. If you have a dependent t-test and ordinal data, the sign test and the Wilcoxon signed ranks tests are appropriate. We'll now turn our attention to the n-sample case. The parametric test, independent groups ANOVA. If your dependent variable is nominal in nature, the non-parametric equivalent test is the chi-square test for n independent samples. If the outcome measure is ordinal in nature, then the Kruskal-Wallis test is appropriate. If you have a repeated measures analysis of variance, the non-parametric equivalents are the Cochran's Q test if the dependent variable is nominal, and if the dependent variable is ordinal, the Friedman two-way ANOVA by ranks test is appropriate. We'll now turn our attention to SPSS and some of the more commonly used non-parametric statistical tests. We'll illustrate them with SPSS and provide examples of non-parametric statistical tests.